If you want to find the secrets of the universe, think in terms of energy, frequency, and vibration. Nikola Tesla. In April 1955, a great scientist of our era passed away. And on that day, every newspaper published a picture of his desk, and the caption read, "The unfinished manuscript of the greatest work of the greatest scientist of our time." People asked themselves, why couldn't he finish it? What's so hard? It was the theory of everything, the unified field theory, an equation that would summarize all the physical forces in the universe. That was the desk of Albert Einstein. String theory is one of the most brilliant, controversial, and unproven ideas in all of physics. At the heart of string theory is the thread of an idea that's run through physics for centuries, that at some fundamental level, all the different forces, particles, interactions, and manifestations of reality are tied together as part of the same framework. Reality is merely an illusion, albeit a very persistent one. This famous sentence was uttered by the famous Albert Einstein. But what did Albert Einstein mean here? Another great mind, Nikola Tesla, said, "If you want to find the secrets of the universe, think in terms of energy, frequency, and vibration." What exactly did Nikola Tesla and Albert Einstein think about, along with many other famous scientists who changed the understanding of our world? Many people scatter with quotes from Albert Einstein and Nikola Tesla, but how many of them actually understand what they're talking about? With the help of these brilliant people and their understanding of the universe, we've reached the step of a revolution that can change this world fundamentally, since we cannot even begin to try and understand the higher dimension of parallel reality unless we understand the world we live in first. Everything you can see, touch, and feel is made up of atoms, the infinitesimally small constituent parts of matter. Atoms are what make up the matter we interact with every day. You, your bed, your chair, and everything else. An atom is a positively charged nucleus with negatively charged electrons orbiting it with a great deal of empty space between them, and two atoms can never touch each other. Why? Because of the electromagnetic force that exists between them, which states that electrons will repel each other. When you lie in your bed, the electrons within your body and the electrons that make up your bed repel each other. Thus, you hover above your bed by a tiny distance. If you can never truly touch something, how is it possible that you can feel the textures of an object? As you may have guessed, it's the electromagnetic repulsion between the electrons of your body and the object that you're sensing. The nerves in your body send signals to your brain with the perception that you are physically in contact with the object. However, in reality, you're not really in physical contact with the object. The atoms of your body and the atoms of your bed repel each other through an electric force. Atoms that vibrate at a certain frequency interact with each other. At this very moment, you may actually understand what Nikola Tesla was talking about. The vibrations and frequencies of the atoms interact with each other to create the world and the reality you're witnessing right now. The entire world, everything you've ever seen and everything you ever will see, is made up of atoms that vibrate at a certain frequency. It's quite scary to think you've never touched anything, including your pet, pillow, or significant other. Welcome to the world of quantum physics and mechanics, a branch of physics that revolutionized the world of science in the early 20th century. The branch of physics that came closest to deciphering the reality in which we live, the reality which is persistently merely an illusion. I'm sure some of you will wonder, if electron repulsion prevents us from ever truly touching anything, why do we perceive touch as a real thing? The answer boils down to how our brains interpret the physical world. In this case, a number of factors are at work. The nerve cells that make up our bodies send signals to our brains that tell us we're physically touching something, when the sensation of touch is merely given to us by our electrons' interaction with the electromagnetic field permeating space-time. Both the universe and the entire world are just one vibration, one illusion, and your brain is nothing but a biological decoder of that kind of reality. This leads us to try and solve a mystery called quantum physics and mechanics, because its basics are relatively easy to understand. However, the meaning behind it is what eludes even the most intelligent minds that have ever walked this earth. Einstein spent the last 30 years of his life chasing after an equation perhaps no more than 1 inch long that would allow him to read the mind of God. That was the ultimate goal, the holy grail of physics. Einstein wanted an equation that would unify gravity, electromagnetic force, and the 2 nuclear forces. He wanted unification of all 4 forces into one theory, the theory of everything, the God equation. Physics is quite useful. When Newton worked out the mechanics of moving objects and gravity, he helped to lay the groundwork for the Industrial Revolution. And then Maxwell and Faraday united electricity and magnetism to give us the electromagnetic force, the electric revolution of dynamos, generators, and light bulbs. And now we have E equals mc squared, which helped to pave the way for the nuclear force. Each time a force was unraveled, it changed human history. And now, we want to put the whole thing together into the God equation, fulfilling Einstein's original dream. Albert Einstein's general theory of relativity provided physicists with both an improved understanding of gravity as well as new unanswered questions. While it was groundbreaking, it wasn't able to describe gravity as a consistent quantum theory or one that successfully describes all the forces of nature. To this day, Einstein's dream of linking gravity with electromagnetism and the strong and weak nuclear forces into a single framework has yet to be realized. And now, it's time we go beyond Einstein. Physicists like Michio Kaku and Greene believe that string theory is perhaps the theory of everything. When we smash atoms, we find more particles, lots and lots of particles. So why should nature be so malicious as to give us thousands of subatomic particles? In fact, the situation was so bad that J. Robert Oppenheimer, the father of the atomic bomb, once said that the Nobel Prize in Physics should go to the physicist who does not discover a new particle this year. Here's the new idea of string theory.
Imagine I have a beautiful tree that's filled with oranges. And I ask myself, what is the orange made of? How do I answer that question? Well, I want to look deeply inside the orange, so I magnify it. And I magnify it again, and if I keep on doing it, deep inside, sooner or later I begin to see molecules come into view. But molecules are not the end of the story, because the molecules, I can enlarge them. And if I make them big enough deep inside, I begin to see atoms. Atoms are not the end of the story too, because we have electrons zooming around the nucleus. Deep inside, mostly empty space in the atom, but deep inside, we see the nucleus. So if I grab that and magnify it, I see that the nucleus is itself made of particles, neutrons and protons. And if I grab one of the neutrons and magnify it, I find yet further particles, little tiny quarks inside. Now that is where the conventional ideas stop. String theory comes along and suggests that inside these particles there is something else. So if I take a little quark and I magnify it, conventional idea says there's nothing inside, but string theory says I'll find a little tiny filament, a little filament of energy, a little string-like filament. And just like the string on a violin, I pluck it and it vibrates, creates a little musical note that I can hear. The little strings in string theory, when they vibrate, they don't produce musical notes, they produce the particles themselves. So a quark is nothing but a string vibrating in one pattern. An electron is nothing but a string vibrating in a different pattern. A neutrino, nothing but a string vibrating in a different pattern still. So if I take all of this back together, I have my ordinary orange, and if these ideas are right, they are speculative, but if they are right, deep inside the orange or any other piece of matter is nothing but a dancing, vibrating cosmic symphony of strings. That's the basic idea of string theory.
So if these ideas are correct, this is what the ultra-microscopic landscape of the universe looks like. It's built up of a huge number of these little tiny filaments of vibrating energy, vibrating in different frequencies. The different frequencies produce the different particles. The different particles are responsible for all the richness in the world around us. And there you see unification, because matter particles, electrons and quarks, radiation particles, photons, gravitons are all built up from one entity. So matter and the forces of nature all are put together under the rubric of vibrating strings. And that's what we mean by a unify theory. This theory, string theory, is a quantum theory, and all quantum theories say that everything vibrates. Everything is made of a wave, and because of that, these waves intertangle with each other. That's called entanglement. And entanglement means our waves entangle with waves on the other side of the galaxy. Instantly, in fact. We're all connected via this invisible web. Einstein at first didn't like this picture, because if you were to move in one part of the universe, the other part of the universe will also respond to you faster than the speed of light. But it's been shown in the laboratory with the famous EPR experiment. It's been shown many times now that entanglement does in fact make possible vibrations traveling faster than the speed of light. Now, here's the catch. When you study the mathematics of string theory, you find that it doesn't work in a universe that just has 3 dimensions of space. It doesn't work in a universe with 4 dimensions of space, nor 5, nor 6. Finally, you can study the equations and show that it works only in a universe that has 10 dimensions of space and 1 dimension of time. So what are we? The subatomic particles, the nodes on vibrating strings. What is physics? Physics is nothing more than the laws of harmony you can write on the strings. Then what is chemistry? Chemistry is nothing but the melodies you can play on vibrating strings. Well, what is the universe? The universe is a symphony of strings. And therefore, what is the mind of God? The mind of God in this picture is cosmic music resonating through 11-dimensional hyperspace. These strings are not ordinary strings. These strings force physical reality to be 11-dimensional. What is the implication then, if we're not just third-dimensional? What does this mean to us? According to theoretical physicist Dr. Michio Kaku, our universe is probably a soap bubble, a 3-dimensional soap bubble floating in 11-dimensional hyperspace, that if we were to leave our universe to go to another universe, we would have to take a detour through the 11th dimension. Dr. Kaku thinks that at one point when the universe dies, this may be our only salvation.
You know, trillions of years from now, the universe is going to get awfully cold. We think the universe is headed for a big freeze. All the stars will blink out. Stars will cease to twinkle. The universe will be so big, it'll be very cold. At that point, all intelligent life in the universe must die. The laws of physics are a death warrant to all intelligent life. There's only one way to escape the death of the universe, and that is leave the universe. We are now, of course, entering the realm of science fiction, but at least we now have equations, the equations of string theory, which will allow us to calculate if it is possible to go through a wormhole, to go to another universe where it's warmer, and perhaps we can start all over again.
Einstein's theory of relativity does a fantastic job for explaining things. Quantum mechanics is fantastic for the other end of the spectrum, for small things. The big problem is that each theory is great for each realm, but when they confront each other, they're ferocious antagonists, and the mathematics fall apart. String theory smooths out the mathematical inconsistencies that currently exist between quantum mechanics and the theory of relativity. It posits that the entire universe can be explained in terms of really, really small strings that vibrate in 10 or 11 dimensions, meaning dimensions we can't see. If it exists, it could explain literally everything in the universe, from subatomic particles to the laws of speed and gravity. The biggest objection is you can't test it, but we're getting closer and closer to being able to. So what is this unified field theory, the theory of everything can do for us? Is it going to give us a better TV? Will we get better smartphones or faster internet? The theory of everything blows your mind. It allows for the presence of perhaps time machines, wormholes, the universe before the Big Bang, parallel universes, the multiverse, things out of the Twilight Zone. Recent discoveries in physics and astronomy, physicist Greene says, point to the idea that our universe may be one of many universes populating a grander multiverse. Greene thinks the key to understanding these multiverses comes from string theory. That theory, he says, might be testable in the Large Hadron Collider, or LHC, at CERN, the European Organization for Nuclear Research. In the end, labeling one realm or another a parallel universe is merely a question of language. What matters, what's at the heart of the subject, is whether there exists realms that challenge convention by suggesting that what we've long thought to be the universe is only one component of a far grander perhaps far stranger and mostly hidden reality. During the last half-century, science has provided ample ways in which this possibility might be realized. Quantum mechanics broke the mold of the previous framework, classical mechanics, by establishing that the predictions of science are necessarily probabilistic. After decades of closely studying quantum mechanics, and after having accumulated a wealth of data confirming its probabilistic predictions, no one has been able to explain why only one of the many possible outcomes in any given situation actually happens. When physicists do experiments, when they examine the world, they all agree that we encounter a single, definite reality. Yet more than a century after the quantum revolution began, there is no consensus among the world's physicists as to how this basic fact is compatible with the theory's mathematical expression. We've never been closer to solving this mystery, while at the same time, so far away, and, at the moment, neither our best scientists nor the most advanced devices we have can help us. But ideas and visions exist, and it is only a matter of time before we obtain more answers, which will surely raise new questions about the universe itself and the reality that surrounds us. A reality that is merely an illusion, albeit a very persistent one. Thank you for watching, and hit the like button if you enjoyed this video. We really hope you subscribe, and if you'd like to be notified of future releases, just hit the bell button. Leave a comment. Let us know what your thoughts are on all of this and what topics you'd like to explore in our future videos.